everyone. We're back to look at SOL 3.2 notes and practice. So this is about fractions. This unit or this SOL strand is going to cover fractions for us. So we've already learned fractions in class, so this is all just review for everyone. A fraction is a way of representing part of a whole, as in a region/area model or a measurement model. Measurement models are number line, or a part of a group, as in a set model. Fractions are used to name parts of one thing or part of a collection of things. So this shows the whole. This is a whole with 1/4 shaded. And we know that because the 4 is the denominator, which is how many parts there are. And the numerator, which is the number on top, is what's the shaded area. The group is a shaded set of 2/3. We know that because there's 3 parts altogether. So 1, 2, 3, and there's 2 shaded, 1, 2. Then we have another shaded one we can look at, like a group, and then another shaded one. So the main thing to remember about fractions is that they have to be equal parts. So we can't have a shape that's divided in crazy parts. These are all equal parts. They don't have to be congruent, so they don't have to look the same, but they have to be equal. So if I had a square and I just decided to have one big part and then a bunch of little parts, that would not be a fraction because these are not equal. So that would not be a fraction. These are fractions because even though they're shaped differently cut, they're still equal, because if I have, this one's the most confusing one to people. So if I have this square, I know it's not perfect, but you cut it in half, right? These are equal parts, right? I cut this half in half, equal parts, and then I cut this half in half. Even though I cut it differently, it's still half of each part. So these would still be equal force. Then we move on to comparing fractions. So we compare using the same ones we've done with numbers. So greater than, less than, and equal to. And when we do those symbols, it's easy for us to remember them if we do. The one with the 2 dots in the front is greater than. The one with the 1 dot in the front is less than. And then we know equal to is just equal. Then you're going to go ahead and do these practice problems down here. So it says, which model is represented for 3/8? So that means we have to have 8 parts all together and 3 parts shaded. So let's count how many parts. 1, 2, 3, 4, 5, 6, 7, 8. So that one does have 8. And then how many are shaded? 1, 2, 3. That was easy because that was the first one. So we know that's going to be 8 because that's 3/8. If we look at C, there's 3 parts shaded, but there's also 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. 11 parts altogether. And that means they just added the 3 shaded and then the 8 unshaded behind it. And that's not how we make a fraction. We have to have 8 parts total and then shade in 3 of those. For this section, you're going to go ahead and compare them. So you need to label each fraction. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The denominator is 11 for both of them. Now you got to figure out how many are shaded. 1, 2, 3, and 4. So you would just set it up. 3 11s, 4 11s. When the denominator is the same, you can just look at the numerators like regular numbers. Is 3 less than, greater than, or equal to 4? And you put the symbol in the middle. Number 12, you're just going to label what this fraction is. And then number 10, you're going to label it as well. The ruler is kind of just like our number line. So think about the number line ones we've done in class before. If you have any questions when you're doing this section, please let me know.